So in this problem, John has $1,000 and he's earning interest rate at a nominal rate of I compounded semi-annually. And then we're interested at the amount he has at time equal to 16. So let's try to find what John has at time 16 first. So he starts off with $1,000 and then he's earning compound interest rate compounded semi-annually, and this is the amount that he has at time 16. So I'm just applying the formula. And then we're going to compare this with what Mary has. So Mary has $1,000 as well. And then after depositing it, she's going to earn at a force of interest of 1 over 5 plus t. So in order to find the amount that she has at time 16, we're going to use the accumulation function. So if you recall the equation after you solve a differential equation, so if you're given a force of interest, you can use this equation to derive the accumulation function. So in our case, her force of interest is 1 over 5 plus y. So that's going to be equal to natural log 5 plus y, 0 to t. So that's going to be equal to natural log, so that should be a 5. 5 plus t minus natural log 5. And then if you recall your logarithms, log a minus log b is going to be equal to log a over b. So in this case, it's going to be natural log 5 plus t over 5. So e to the power of natural log of something, that's just going to be equal to that something, right? So this is our accumulation function. So using this, we can actually find what Mary has at time 16. But notice that Mary starts her deposit at time 2 instead of time 0. So if she deposits her money at time 2, the amount that she has at time 16, some of you might say it's just 1,000 times A14, right? That seems reasonable. But it's actually not. The correct answer should be 1,000 times A16 divided by A2. So I've explained why this is true in our last tutorial, so you can look up on that if you've forgotten. So this is just a revision on that concept. So using this, we can actually find what we're looking for. So we're trying to find I. So we've set up our equation, so we can find I now. So let me just cancel out the 1,000 first. So on the left-hand side, we have 1 plus I over 2, so to the power of 32. And then on the right-hand side, A16 divided by A2, right? So A16 is equal to 5 plus 16 divided by 2. Divided by A2 is just 5 plus 2 divided by 2. 2's cancel out, so it's just 21 divided by 7, which is equal to 3. So we get a nice equation. And then using our calculator, you can just take the 1 over 32th power, and then you can find I. And if you take your calculator and do the calculations, you'll find that I is equal to 0.0698555534.